Hi, in this video we're going to talk about sharing the load. So what do we mean by sharing the load? Well, let's take a look for a minute at a PCB track. So we could have a track of 2mm in width, for example, and that would have a certain amount of current that can be passed through it before we start getting issues such as overheating and voltage drop. Now if we want to pass more current through that, we could coat the top of the track in solder if we leave the track bare and add more solder. That's a very typical practice. If you're tight on space especially, we could make the track bigger. If we double the width of the track, we can effectively double the amount of current that can be carried through that track. And again, if you added more solder on top of that, you could effectively sort of add maybe up to double again. Now, talking of PCB tracks, if you want to get some super high quality PCBs made in next to no time, why not check out my sponsor, PCBWay. With PCBWay, you can get high quality PCBs from just $5 for 10 boards. Why not add assembly? Starting from just $30 for 1 to 20 boards. PCBWay offer a high quality professional manufacturing service from prototype to fully assembled boards, flex PCBs and more. Check them out in the link below. So apart from PCBs, where else might we see this kind of practice taking place? Certainly in the UK, we tend to use what they call a ring main for our power sockets. Don't tend to use it so much for lighting, but you can of course do it that way if you want to. So what do we mean by a ring main? So if we say that we've got our fuse board, or as we're known as consumer unit, and here we've got just say 3 double sockets. Now typically this would be wired with 2.5mm square wire, and we would have our live and neutral. Obviously we're going to have earth as well going into each of these sockets, but for this demonstration we're just representing it as live and neutral, or line and neutral as it's known. So we have our line and neutral go into one, branch out into the next one and back into the next one. So you may have say 3 sockets, but most likely you're going to be talking about having say your lounge, hallway, etc. probably just on one complete circuit. Kitchens typically on a separate circuit. So this would be what we known as a sort of radial circuit. So we are supplying each individual socket and then it ends at that point. So there is going to be a sort of limit to how much current this wire can handle. Now of course you could double this wire up and put in, say, I don't know, typically you can't really get 5mm wire as such, so say 6mm wire, but that's not very practical, and due to like the size of the conductors, etc. So one way we can get around that is to actually loop back from the last socket. So if we imagine that here we've got the line and neutral, basically these two would be connected, so they will be the same sort of terminal on the consumer unit, and then effectively you're going to take that back like so. So now we've actually got, as the term ring would suggest, we've got our power going into one socket, out into the next one, etc., and then runs back to the consumer unit. So that way we can still use the 2.5mm wire, but we can effectively handle maybe up to double the current. Now if we put that aside, we can do a very simple demonstration of that. So say for instance you have a project you're working on, electronics project. You may have some wire line around. I'm just using these little jumper wires with crocodile clips for this demonstration. So you may have a certain size wire that you have lying around and you want to use, but you may find that the typical current you're trying to pass through it is going to be a bit too much for it. You're going to risk overheating. You certainly don't want to risk having a fire because the wires are too thin, sorry. And maybe you just want to get something done quickly. You don't want to fork out and buy some much thicker wire. So this is just simply just a piece of wire that's in a loop connected to the power supply. So if we turn the power supply on, I've currently got it set at 12 volts and 2 amps. This wire will carry 2 amps but not be very happy about it. Voltage doesn't matter here, this is just a very simple demonstration. So this wire is certainly starting to warm up a bit, and if we bring in our current meter here, we can see what kind of current we're getting through this wire. So we will set this to DC volts, 0 the meter out, and if we pop this on the wire, we can see there that we're drawing pretty much 2 amps through that cable. Now, like I said, if we use a thicker cable, we still have 2 amps going through the single cable. Now this is definitely starting to warm up quite a fair bit now. So by using 2 cables, we can effectively split that across. So how does it work? So we're going to connect our black one basically across like that, so that now effectively we have the power running through both of the cables. And if we now check across the 2, we can see we've got the same current, 1.957, so around 2 amps of current there. Now what about if we check an individual cable? Now this is where we get to see how the system is actually working. So effectively it's going to be splitting the current between the 2 cables, so each cable is sharing the load. So if we look across this one here, we can see we have 0.897, so just under 1 amp of current, and so we should expect to see very similar on the second cable. Very similar, this one is just over 1 amp. Now this is just due to variances in these cables. Most likely resistance is going to be very slightly different between the 2, so naturally the current is going to be very slightly different there. Now of course we could add another cable and see what happens if we do that, so let's watch and see how that will drop down once we add another one. So we're currently at 1 amp, and there we are, dropped down to 700 milliamps. So that's with 3 cables, and just for demonstration's video we will add another cable, and we should expect that to drop down probably to about sort of 450 milliamps to 500 milliamps based on our 2 amp current we're trying to pull through it. And yeah, we've dropped down to 600, so a bit higher than what I was expecting. But like I say, there'll be different resistances in these cables, so we can try different cables. We've got pretty much 500 milliamps on that one, and we got there 400 on that one. Now of course in reality you're not going to want to have 4 different cables running to everything for one sort of effectively one run of wire for your project, but it just sort of gives you an idea how, if you are just sort of using one type of cable and it's the size you've got and you want to put a bit more current through it, then yes, you can just go ahead and add an extra cable, and then that will split the load between the 2 cables, and then you should be able to get away with the whatever size cable you've got at the time. So that's a very quick video, guys, just to give you an example of how that sort of system works and where you might need to use it. If you haven't subscribed, please do subscribe, guys. Please ring the bell, then you'll get notified as soon as any new uploads are released. And please leave your comments below, let me know what you think, if you've used this sort of practice yourself, and please give it a thumbs up, guys, that really does help. And I'll see you soon for the next video. Cheers.